In this video, I'll talk about some sample problems involving more operations on sets. So in this problem, we have two sets. A is the set containing 2 and 4, B is the set containing 1, 2, and 8, and we want to list all of the elements of the power set of A union B. So let's make sure we understand these symbols here. So this symbol is the union, which means that we're taking the set A and the set B and combining all of the elements into one big set. And then this set, symbol here is the power set, which means what we really want is a set containing all of the subsets of that set that we get by taking A union B. So let's work from the inside out and first figure out what's A union B. So all we need to do is list all of the elements of A and all the elements of B. We don't need to repeat any elements. So in this case, we're going to get 1, 2, 4, and 8. So that's the union that we get for A union B. Now, when we're thinking about the power set, this set has 4 elements, but it has lots of subsets. So the way that I would recommend approaching this is to be kind of methodical. Let's list all of the subsets that have 0 elements, all of the subsets that have 1 element, all of the subsets that have 2 elements, and so on, until we get to all of the subsets that we're looking for. So the power set here is going to be, well, there's only one subset that has 0 elements, that's the empty set. What about all the subsets that have 1 element? Well, that's each of these individual elements by itself in one set. So that's going to be the set containing 1, the set containing 2, the set containing 4, and the set containing 8. All right, now we're looking at sets containing 2 elements. Well, 1 can get paired with any of the other elements. So 1 and 2, 1 and 4, 1 and 8. 2 can get paired with any of the elements, but we already paired it with 1, so we can pair it with all the other elements. 2 and 4, 2 and 8. 4 can get paired with any of the elements, but we've already paired it with 1 and 2, so we just have 4 together with 8. And we've got all of the pairs of 8 with any of the other elements. So we're done with elements that have, or subsets that have 2 elements. Subsets with 3 elements, well, think of this as which element is missing, because we have 4 elements total, so a subset with 3 elements is going to be missing one of the elements. So a subset that's missing 1 would be 2, 4, and 8. A subset that's missing 2 would be 1, 4, and 8. A subset that's missing 4 would be 1, 2, and 8. And a subset that's missing 8 would be 1, 2, and 4. And finally, subsets with 4 elements, well, that's the whole set. So 1, 2, 4, and 8. And that is our power set. Now this problem looks pretty similar, but it's actually significantly different, because what this is saying is we want the power set of A and the power set of B, and then we want to take the union of those two sets. So we've got 2 separate power sets to take here. The power set of A is going to be all of the subsets of A. A only has 2 elements, so it doesn't have that many subsets. It's got the empty set, as usual. It's got each element by itself, and then it's got the whole set A. And then the power set of B, B has 3 elements, so we have a few more to find. We've got the empty set as always. We've got each element by itself. Then we've got subsets with 2 elements, so that would be 1 and 2, 1 and 8, and 2 and 8. And then we've got the whole set itself, 1, 2, and 8. Okay, so now we want to take the union of these 2 sets, which means we want one big set that contains all of the elements of either of these 2 sets. And we want to make sure that we're not repeating ourselves. So the empty set is in both, so that's included in the union. And what I'm going to do is I'm going to put a little check mark next to every one that I write, so I don't forget any, but also so that I don't write anything twice. Okay, let's look at subsets that have 1 element. Well, we've got 1 by itself, so that checks here. We've got 2 by itself, which checks here and here. We've got 4 by itself, and we've got 8 by itself. So that checks here and here. Sets that have 2 elements, we've got several of those. We've got 1 and 2. We've got 1 and 8. We've got 2 and 8. And we've got 2 and 4. We didn't have any repeats there, so check, 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 check. And then finally, we've got 1, 2, and 8. And that checks there. And there's our union. All right, now for this last question, we're talking about partitions. So a partition of a set is simply a way to break the set into one or more subsets. In this case, we're specifically being asked for a partition where each part has a different size. Now, when I talk about the parts of a partition, I'm talking about those subsets that I'm breaking this set into. So if I want every part to have a different size, well, in total, my parts are going to add up to the original 8 elements that I have in my original set. So there's different ways that I can do this. I could have a part of 3 numbers and the other part has 5 numbers. Or I could have 1 number by itself and then 3 numbers and then 4 numbers. There's different ways to break this up. Let's do 3 different parts. So I could have 5 by itself. I could have 1, 7, and 8 by itself in one part. And then what's left over? We got 2, 3, 4, and 6. So that's one of the many ways that we could do this. So each of these is a part. So we've got 3 parts, and they each have a different size. They each have a different number of elements. Again, another way I could have done this would have been 1, 2, 3, and then 4, 5, 6, 7, 8. There I have 2 parts, but again, each of the parts has a different size, so that's another valid solution here. So there's lots and lots and lots of ways to do this. But it's a partition because there's no overlap between any of the parts, and we get every element. Every element of the original set is in some part. So that's what it means to be a partition. Every element is in one of the subsets that you have, and no 2 of the subsets have any elements in common.